So here, how to find out? Suppose there is no h1 loop here, then with only h2 alone, then we find out g2 by 1 plus g2 h2, because one more feedback is coming through h1, so this can be converted as g1 g2 h2 h1 into h2 cs by rs plus minus this plus minus. Okay, now you find out g2 by 1 plus g2 h2 is a closed loop, this one, then multiply with g1, then finally close loop with h1 by h2. Yes, so you will get the answer ts equal to cs by rs, that equal to g1 g2 divided by 1 plus g1 h1 minus g2 h2. So this is the answer for this problem. Okay, so next we'll see some of the previous gate problems. We'll see one gate 2010 EC. They asked one problem: find the transfer function ys by rs. Find transfer ys by rs. Now the problem is 1 by s plus 1, 1 by s plus 1, yes, this is ys, this is rs. So how to find out the transfer of ys by rs? The choice given as a is 0, b as 1 by s plus 1, and c as 2 by s plus 1, and d as 2 by s plus 3. So how to solve this problem? So by using block diagram reduction techniques, we will see the move a takeoff point after the block 1 by s plus 1, then you will get step is move a takeoff point after a block. So after moving this takeoff point 1 by s plus 1, 1 by s plus 1 into s plus 1. Okay, so this both gets cancelled, you will get only 1. So this is minus 1, this is plus 1. So the output will become 0. That means there is no loop in this. Because of 0, the loop is cancelled now. You will get only ys by rs equal to 1 by s plus 1. This answer is B. So we are using the technique, the block diagram reduction technique, as moving a takeoff point after a block. It will be easily simplified. So this way the problem they will give the basic basics of control systems problems. The next problem is based on block diagram reduction techniques. Very simple problems only they asked in block diagram reduction techniques. That is moving a takeoff point after the block or before block. So such problems, based on that only they asked problems. Okay, not a much problems on this block diagrams concepts. Okay, so the next topic is signal flow graphs. Signal flow graphs. Next topic, that is a somewhat easy method compared to block diagram reduction techniques. That is signal flow graphs. Actually, what is the difference between signal flow graph method and block diagram reduction techniques? This is a graphical method, and that is a pictorial representation. Is a graphical representation. That is the signal flow graph. A signal flow graph is a graphical representation of the relationships between the variables of a set of linear algebraic equations. Set of linear algebraic equations. Next point, it consists of a network in which nodes representing each of the system variables are connected by directed branches. So how it connected? It consists of a network in which representing each of the system variables are connected by directed branches. Directed branches. For example, you take one representation as a signal flow graph. This is x2 and gain is a. You write x2 equal to a into x1. The next representation of signal flow graph is this is a1, this is a2, x1, x2, x3. So x3 equal to a1 x1 plus a2 x2. So this will represent the signal flow graph, the basic. The next representation basics of signal flow graph is, for example, this is x1, here it is x2, for the x3, a, b. So it can be written as a into b, x3, and this is x1. For example, another representation of signal flow graph is this is a and feedback with minus b. This is x2, x1. So to write x2 value, x2 equal to a by 1 plus ab. So why is ab? Because it's a negative feedback, right? Then another example, let's see, this is a, b, and this is a c, x1, x2, x3. So finally you will get the c, sorry, this is a and this is b by 1 minus bc. So finally you will get ab by 1 minus bc. So this is the x3, x1. Yes. So like that we will find out the signal flow graph, simple signal flow graphs. Okay. Suppose complicated signal flow graph is given. then we have to use the Mason's gain formula. Mason's gain formula. So Mason's gain formula, Ts equal to Cs by Rs, that equal to 1 by delta sigma k pk delta k, where Ts is the transfer function system and pk is the forward path gain of kth forward path gain of kth forward path, and k is the number of forward paths, and delta k is 1 minus any loop gain which is not touching the kth forward path. 1 minus any loop gains, it may be more than one loop also. So that is the delta k. For example, delta 1, if I take 1 minus any loop gains which is not touching the first forward path. Yes. Next, delta. What is delta? So delta is 1 minus sum of individual loops, sum of loop gains of individual loops plus sum of gain products of two non-touching loops minus sum of gain products of three non-touching loops plus and so on. So like this we will find out the transfer function by using Mason's gain formula. Now we will solve some of the problems based on this criteria, this technique. Now we will see some problems. Yes, first problem, find Cs by Rs using Mason's gain formula. 1 G1 G2 G3 G4 G5 is Cs Rs. Next, G2 will have the feedback as minus H1, and from after G3 onwards this is minus H2, and G5 will have the feedback minus H3. Then another forward path, that is a G6. This is G6. Yes. So this is the problem is given. Now how to find out the transfer function by using Mason's gain formula? First you have to identify the k value. What is the number of forward paths? So k value is from input Rs to output Cs. The number of forward paths we have to find out. First one, G1, G2, G3, G4, G5, yes, Cs. This is the first forward path as a k value is 1. Then another forward path also there, 1, G6 and G4, G5, Cs. Yes, that means k value is 2. So once you decide the k value, then Ts equal to P1 delta 1 plus P2 delta 2 divided by delta. Yes, what is P1? P1 is G1, G2, G3, G4, G5. Then what is delta 1? Delta 1 means 1 minus any loop which is not touching with first forward path, then there is no loop like that, it will be 0 only. Next, second forward path is G4, G5, G6, and 1 minus any loop which is not touching with this forward path, there is a loop which is minus G to H1. So minus or minus plus G to H1. Yes. Simple. Next, what is delta? So delta is 1 minus individual loop gains. So minus G to H1 and minus G2, G3, H2, then minus G5, H3. This is the individual loops. Next, two non-touching loops plus two non-touching loops, there is a G2, H1 multiplied with G5, H3. So you will get G2, G5, H1, H3. Next, plus G2, G3, H2 and G5, H3. So finally, G1, G2, G3, G4, G5 plus G4, G5, G6 plus G2, G4, G5, G6, H1 divided by 1 plus G2, H1 plus G2, G3, H2 plus G5, H3 plus G2, G5, H1, H3 plus G2, G3, G5, H2, H3. So this is the transfer function by using Maslinger formula. Next, another problem. Find CS by RS. This is G1. Next, G2, G3, G4, G5 minus H1, G2 minus H2, G6 minus H3, yes, okay. Now find out the K value. First, this is RS input. So G1, G2, G3, G4. This is the first forward path. The next G1, G2, G6 is the second forward path. So K value is 2. So now the TS equal to P1 delta 1 plus P2 delta 2 divided by delta. Now what is P1? G1, G2, G3, G4 into delta 1. Any loop which is not touching this forward path, 1 minus 0. Next P2, G1, G2, G6 into 1 minus any loop which is not touching with this forward path, yes, 1 minus G5, yes, divided by 1 minus individual loops minus G2, H2 minus G2, G3, H1, then minus G2, G3, G4, H3 minus G5. These are the individual loops. Then two non-touching loops plus minus G2, G5, H2. Oh, one more individual loop is G2, G6, S3, correct, minus G2 G6 S3 also it is there, yes. Two non-touching loops, G2 G5 S2, then G2 G6 S3 and G5, that is also another non-touching loop. So you will get plus, I think. So G2 G6 S3 into G5. Any three non-touching loops are there? No. So this will leave as it is. Then final equation you will get G1, G2, G3, G4 plus G1, G2, G6 minus G1, G2, G6, G5 divided by delta. Delta we have found already, the same value we will write here. So this way you can find out the transfer function by using signal flow graph, that is the Mason gain formula. Now we will see some of the gate problems, previous gate problems. So one more method also there, that is one more, means a different type problem. It's not a method, it's a different problem. Yes, that is the third problem in signal flow graph. Find CS by RS minus H2 G5 G8 G4 G1. This is G4 minus H1 G2 G3. This is 1. Last is G6, this is G7. Fine. So here, how to find out the K value? Once you find out the K value, then you can easily use the Mason gain formula. This is G2, G4, G6 is one path, and G3, G5, G7 is another path. The K is 2, then 1, G3, G8, G6 is another, then G2, G1, G7 another path, 4, one more G3, G8, H1, G1 is, so finally you will get K value is 6. So TFS equal to P1 delta 1 plus P2 delta 2 plus P3 delta 3 plus P4 delta 4 plus P5 delta 5 plus P6 delta 6 divided by delta. Okay, so you can check it answer. I'll write the answer directly. G2 G4 G6 1 plus G5 H2 plus G3 G5 G7 1 plus G4 H1 plus G2 G1 G7 plus G3 G8 G6 plus G2 G1 minus H2 G8 G6 plus G3 G8 minus H1 G1 G7 divided by 1 plus G4 G7, sorry, this is H1 G5 H2 minus H1 H2 and G4 G8 plus G4 H1 G5 H2. Okay, so this is the answer for this problem, and now we will see some of the previous gate problems. For example, we take the gate problem, gate 2003 EC. Find out the transfer function CS by RS by using Masonian formula or second flow graph. The problem is, yes, this CS is RS. Okay. Now for this problem, what is the K value? So K is only 1. This is the path. So K is 1. So TS equal to P1 delta 1 by delta. What is P1? 1 into delta 1, 1 minus any loop which is not touching this forward path. So there is a 1 by s into minus 3. That means minus 3 by s. Minus or minus plus will come. So we will get plus, then another minus plus minus 24 by s divided by 1 minus individual loop minus 2 by s minus 24 by s minus 3 by s plus 2 non-touching loops minus 2 by s into minus 3 by s means 6 by s square. So you will get 1 plus 27 by s divided by 1 plus 29 by s plus 6 by s square. So you will get s plus 27 by s into s square by s square plus 29s plus 6. So s gets cancelled. You will get s into s plus 27 divided by s square plus 29s plus 6. This is the answer. So the choice given as ABCD. So D is the answer. Answer D. So you can refer the gate 2003 problem EC. Okay. The next problem, the next gate problem we'll see. Gate 91 EC. Find the C S by RS. This is very simple problem only. 1 is 2, 3 gains 4 from 1 to 4. This is 5, and for every loop there is a feedback as minus 1, minus 1, minus 1. Okay, right. So this is CS RS. So how to find out TFS? We have to find out first the K value. So K is 1, 2, 3, 4 is the one first forward path, then 1, 5 is another forward path. So K value is 2. So P1 delta 1 plus P2 delta 2 by delta. What is P1? 2 into 3 into 4. That means 6 into 4, 24. 24 into 1 minus 0 plus what is P2 is 5. So 5 into 1 minus, this loop is 3 minus 1 is the loop which is not touching this second forward path. So 1 plus 3 divided by, what are the individual loops? 1 minus 2 minus 3 minus 4, and then 2 non-touching loops 8. So this is minus 2 into minus 4, so 8 you will get. So this will be 24 plus 20 divided by 1 plus 9 plus 8, 18. Actually, one more is there. So that is minus 5. Minus 5 means 13 will come. 9 minus means that is 14. So you will get 44 by 23. This is the answer. The next question, gate 98, they asked a simple question. Find the y by x 5, this is 2, this is 1 minus 2. So this is x, this is y. Okay, so how to find out the transfer function? Y by x equal to, so this is a closed loop, so we can simplify. This is 5, you will get 2 by 1 plus 4 into 1, this is y, this is x, so 10 by 5 you will get 2, finally 10 by 5 you will get 2, so y by x equal to 2 1. So like this very simple problems they asked in GATE exam. Okay, so with this unit will wind up. The next chapter is we'll move on time domain analysis, that is the time response analysis.